Good morning, everyone. It is Friday, March the 20th, and we've got a couple of news stories to talk about for this upcoming weekend. First thing we need to discuss is this ridge that's building from the West Coast eastward into the Great Lakes in the mid-Atlantic as we move into the weekend. And with it, we'll have a storm track that goes from Washington State again into the Great Lakes and the mid-Atlantic, providing two storm systems really that could provide some severe weather as we get into the weekend. And where we have the boundary between the warm and cold air, we'll actually have some severe weather as we get into the day Sunday. And one of the places I'm showing you here on the screen is Cincinnati, Ohio. Another location that could experience severe thunderstorms is Louisville, Kentucky. Now, here is the forecast map around 6 p.m. on Sunday. Now, the thunderstorms that you see on Sunday on the radar will probably not resemble what you're seeing here, but just in general, along the Ohio River Valley, if you live in Kentucky, West Virginia, north and eastward into the state of Pennsylvania around this time, there could be a line of thunderstorms here. And out ahead of it, we could have a few supercells that form. Now, as mentioned before, we will have some storm systems moving through the Great Lakes and the Northeast through the weekend. The first one we see here on Friday, moving out of the Great Lakes, will actually be pretty weak by comparison in terms of the storms that will be generated here over the Northeast and the Mid-Atlantic. We'll likely see just scattered showers and thunderstorms to the south of this low pressure system, tracking across the Great Lakes into the Northeast through Friday night. On the northern side of this, we'll likely see a brief burst of snowfall over New York State, especially near the border of the US and Canada here into Vermont, New Hampshire, and even Maine. Now, behind it, we'll have a new system, a new Alberta Clipper, more or less, that's moving into North Dakota as we get later in the day Saturday. This will be system number two here that gets going Saturday into Sunday. And we can see that better here in the forecast map. This particular animation here takes that low pressure across the Great Lakes into the Northeast. But one big difference here is that we'll have a line of showers and thunderstorms that's generated probably early in the day Sunday, continuing through Sunday night. And this will be highly dependent on the instability ahead of these thunderstorms and also the daytime heating. Now, this particular model does show those showers and thunderstorms quite heavy over the Ohio Valley, but as soon as they hit the southern Appalachians, they do begin to fall apart. And we'll watch this over the next couple of days and see if it does play out this way. It looks like mainly a Ohio Valley event here, at least in terms of severe weather. Now, one of the things we'll be looking at is the dew points over the next couple of days. And wherever you see blue on this map here, we have dew points in the low to mid 60s. And you'll notice Sunday afternoon how far they reach into the Midwest, into, let's say, Illinois, Indiana, Ohio, and perhaps even southwestern portions of Pennsylvania. So that's pretty far north for this time of year. Now, this particular animation shows the bulk wind shear. And out ahead of it, we have some light blues and lighter pinks. Now, this is probably the leading edge of the front as it moves into the Ohio Valley and Tennessee Valley, especially late in the day Sunday, early Monday. What we need to do is take a closer look at that here. We will in the next couple of animations. Now, taking a closer look at the dew points here in the Tennessee and Ohio valleys, you can see here by Sunday afternoon, we have those dew points in the low to mid 60s. And we can notice here, let's say around southern Indiana, perhaps even southern Illinois, we see these dew points around 65 and 66 degrees, which is more than enough for supercells to actually get going. Now, these dew points are one ingredient for supercell storms. We actually need wind shear as well. Now, in general, when we get to around 6 p.m. on Sunday, the front will be somewhere here along the Ohio River Valley. Now, ahead of it, what's going to be important is where we have these darker blue areas. I just want to kind of reiterate that we could get some supercell activity out ahead of this main line. Again, you can kind of see these thunderstorms firing up in that general area of the Ohio River Valley. Any storms that are at the leading edge of this will be able to feed off of that instability in the states of Kentucky and West Virginia that we were showing previously. Now, the cities that we mentioned before, Cincinnati, Ohio, Louisville, Kentucky, What I wanted to do is show you a sounding here between those two cities. You kind of make out the red dot here above. This is showing again along the Ohio River Valley what the atmosphere might be like. Now, when you're looking at this grid here, so I'm kind of box it in here so you can kind of focus on this particular area. So what is front and center to us here? There's two lines that we need to take a look at here when we're looking at the instability of the atmosphere. The first line here to kind of point out is the purple dash line. This is basically the air that's saturated at the surface and how it rises in the atmosphere relative to, let's say, the red line here. Indicates how dry air at the surface would rise and cool. Now, depending on the difference between those two lines will tell us how much energy is going to actually be available to thunderstorms that form in this region. And I've highlighted that here for you. You can see this entire red region. And the larger again that is, the more energy available to thunderstorms. And I've kind of boxed in here to the right where you can see the measurement of CAPE here in the middle layer of the troposphere. So in the mid levels of the atmosphere, we have CAPE values of 1,000 joules per kilogram at least. That alone is not enough. We need actually some spin in the atmosphere. And what that is generated by is having changing winds with height, both in the direction and speed. So I'm going to point your attention now to this purple box that I have highlighted on this figure. And I want to point out in particular these flag-like symbols. I'll highlight one of them here in red within that purple box. And the main takeaway here is that when you have more lines, especially longer lines, right, by comparison, that means faster wind speeds. If I were to compare that flag here at the top of the box to the flag at the bottom of the box, you'll notice the one at the bottom has less of those lines. So more or less you have lighter winds at the surface compared to the winds above you. And generally speaking, that's what happens in the atmosphere. But the faster that change from the surface to the winds just above you, that creates more spin in the atmosphere. And this increases so when you change the direction of those winds. So if you take a look again at this box, you'll notice that these flag-like symbols are pointing in different directions. So even though it seems subtle, even the slightest change there can have a great impact. In fact, if we were to go here and follow this purple line to the top right, you'd see another purple box here at the top here. Circle it in for you guys briefly. What I'm showing here is that we have at the surface approximately 15 knots for those surface winds. That's around 15 to 20 miles per hour. And then we have 45 knots, 1, 2, maybe 1.5 kilometers above our heads here at this time. And what that's showing you, again, if you have 45 knots for those winds overhead, that's approximately 45 to 50 miles per hour, the wind speeds above us. And the basics here, this is the main takeaway here. If you were to look at the difference between the two, you notice that both of these lines have different directions on them. One's kind of moving up like this, and then the other one's moving directly to the right. The main takeaway again is that they're changing direction. Again, even though it's subtle, it does have an impact on spin in the atmosphere. And again, a wind speed change from 15 to 45 knots is significant near the surface. Now, this is something that the Storm Prediction Center might put out tomorrow or even Saturday as this event approaches. And who knows, maybe it'll change by then. But I do want to highlight that there is the potential, at least, for something like this happening, especially if we have CAPE values that we're seeing here and then also the wind shear that we're seeing here. Well, guys, we'll leave it at that today. I hope you enjoyed today's video. If you did, like or subscribe, it really helps the channel. There's also this bell icon. If you were to hit that, that will notify you of any future videos that I put out. But I hope you guys have a great weekend, and I'll see you Monday.